My dear friends, welcome to SEKAR classes on applied data science with Python. This is lecture number 97. In this lecture, we will try to understand what is random experiment, what is sample space, what is random variable. In my next lecture, that is in lecture number 98, I will discuss about types of random variables. In my previous lecture, we discussed about introduction of probability distributions. Just see, first we will try to understand what is outcome. An outcome is a possible result of the experiment. Then what is random experiment? An experiment in which all possible outcomes are known in advance, but we don't know which possible outcome occurs. For example, the tossing of a coin. If you toss a coin, what happens? There are two possibilities. You may get head, you may get tail. You know the possibilities in advance, head or tail, but we don't know which possible outcome occurs. Therefore, it is random experiment. Just see the roll of a die. In the case of roll of a die is also, there are 6 possibilities. We know that you may get 1, 2, 3, 4, 5, 6. But we know all possibilities in advance, but we don't know which one occurs. There are 6 possibilities in advance. We know that, but we don't know which one occurs. Therefore, it is a random experiment. In similar manner, you can understand drawing a card from pack of cards. From pack of cards is also a random experiment. Now we will try to understand what is sample space. What is sample space? Sample space is set of all possible outcomes of a random experiment. For example, consider tossing a single coin. This is a random experiment. Why? Because we know all possibilities in advance. What are the possibilities? If you toss a single coin, you may get head or you may get tail. There are 2 possible outcomes, isn't it? If you write all those possible outcomes in a set, that is sample space. Just see, what are the possibilities? Head is one possibility, tail is another possibility. If I toss a coin, I may get head or I may get tail. I am keeping all these possibilities in a set S. Therefore, this set S is sample space for a random experiment of tossing a single coin. Now, let me consider another example, tossing 2 coins. If I toss 2 coins, what happens? There are 4 possible outcomes. If you toss n coins, you will get 2 power n possible outcomes. Here you have 2 coins, therefore n equal to 2. How many coins you are tossing? 2. 2 power n means 2 square. 2 square means how many possibilities? 4 possibilities. What are they? On first coin may be head, second coin may be head. Head, which one? This one is head case. First coin may be head, second coin may be tail. Therefore, this is head tail case. First coin tail, second coin head. This is tail head case, isn't it? Both coins may be tails. Both coins may be tails. I am writing all possibilities in a set S. Head, tail, tail, head, tail, tail. Therefore, this S is known as sample space of a random experiment of tossing 2 coins. If I continue this discussion, if you toss 3 coins, here n equal to 3. What is my n? N equal to 3 means how many possibilities? 2 power n possible outcomes. That is 2 power 3, 8 possible outcomes. This is about first coins. Your first coin may get head or tail. Your second coin will associate with first coin, isn't it? Here also I may get head or tail, here also. third coin that will associate with these things. The third coin head tail, third coin head tail, third coin head tail. Therefore, this is known as tree diagram. You might have learned in your primary classes. This is one possibility, that is 3Hs. Another possibility is 2Hs1T, that is 2Hs1T. Therefore, what is my sample space here? There are 8 possible outcomes that are triple H to so on. Which one is last one? This is first one triple H, last one is triple T. Therefore, there are 8 possible outcomes. In similar manner, you can also understand tossing 4 coins. That is also random experiment. Let me say something about rolling a die. If you roll a die, what are the possibilities for rolling a die random experiment? You may get this phase which consists of 1. This is 2, this is 1, isn't it? This is 1, this is 2, this is 3, this is 4, this is 5, this one is 6. There are 6 phases. All possibilities we are writing in a set. Therefore, that is known as sample space for random experiment of rolling a die. Rolling 2 dice. If you roll 2 dice, what happens? Let me consider like this. This is first die. This is second die. How many phases? 6 phases. 1, 2, 3, 4, 5, 6. Here also I have 1, 2, 3, 4, 5, 6. This is 1, this is 1, 1, 1. This is 6, this is 6. I can say this is 6, 6. Therefore, which ranges from 1, 1 to 6, 6. How many possibilities? There are 36 possibilities. If you roll n dice, then you will get 6 power n possible outcomes. In this case, n equal to 2 dice. Here 1 die, there are 2 dice, 6 square. That's why I am getting 36 possible outcomes, isn't it? Just see now. This one clearly, numerically we are representing. This is 1, 1, isn't it? This is 1, 1. This is 6, 6. This is 6, 6. This set, this entire set S equal to 1, 1 to 6, 6. This set is known as sample space. These are all possible outcomes, isn't it? It is sample space of a random experiment of rolling 2 dice. Now we will try to understand what is variable. If you have ever taken an algebra class, you probably learned about different variables like x, y, and z. Some examples of variables include x equal to number of heads, isn't it? That x is a variable which holds number of heads. Maybe y equal to number of cell phones. Y is also variable which holds number of cell phones. Z equal to running time of movies. Here I can say in basic mathematics, a variable is an alphabetical character that represents an unknown number. That unknown number may be number of heads or number of cell phones or running time of movies. Well, in probability, we also have variables, but we refer to them as random variables, isn't it? A random variable is a variable that is subjected to randomness, which means it can take on different values. As in basic mathematics, variables represent something and we can denote them with an x or a y or any other letter for that matter. But in statistics, it is normal to use an x to denote random variable. The random variable takes on different values depending on the situation. Each value of the random variable has a probability or percentage associated with it. I will discuss what are the types of random variable with appropriate examples in my next lecture, that is in lecture number 98. Thank you very much.